All right, so when we're talking about domain of logarithmic functions, what you want to remember is that the logarithmic function, come on now, it only exists when x is greater than 0, the regular log function, right? So here's 1, and so on. So this is y equals log of x. Doesn't matter the base. This is important, and then the domain for the regular log function. So what you want to think of these is in terms of transformations. So what is happening to the x here inside this log function? So is it moving up, down, left, right? What's kind of the idea, and how can we tell? So if we change x, what does that do? Moving the whole thing up and down, you would think would be numbers outside, up and down, right? So inside the log function, what we would know is that from before our transformations, anything you're multiplying by x, that would be sort of a stretch, a horizontal stretch, right? And what about if you're adding something to x? What do you think that would be? That would be a movement of left and right, right? So if we had log of, let's say, I'm not sure what numbers we want to use. Let's say a is out here. Let's say bx plus c, maybe, and then plus d out here. Or this, maybe we should make this minus c probably, right? Because that's closer to the transformations that we looked at. So if b is greater than 1, that's a sort of a compression, right? Remember that? It squishes in. And if if it's a minus c, that moves everything to the right. And if it's a plus c, it moves everything to the left. Remember that? So if we look at that, let's just test this out. What do you think would be happening here to this base graph? It should be what? What does this 5 do? So is that going to stretch it out, or is that going to compress it with the b? It should compress it. So it actually should go in by a factor of 1/5. So it's going to look, whoops, come on, change. Okay, my computer's not happy right now. It might crash here. So it's gonna squish in by a factor of 1/5. So this is going to be 0.2 right here, right? Okay, so that hasn't changed the domain yet. That doesn't change the domain. What about the 2? If we're looking at 2 as a c value, that's actually 5x plus 2. So that looks like it might move it which way? If it's a positive 2, looks like it should move it left. Now, we don't have that factored in there. I don't know if you remember this, that to get an accurate c value, this should be bracketed like this, right? So this actually, when it's not bracketed, this isn't the actual c. Anyways, but it doesn't, right now, yeah, I guess that does really matter. So let's just test this out. So what we think is that this should be 5x plus 2 over 5. That would follow this form. And it looks like this should move over by 2/5. So that's 0.4 to the left. So from the transformations that we've studied in Pre-Cal 30, that's what's looking like. But let's put this on Desmos and confirm. Or if you have a graphing calculator, you can plug it in to the graphing calculator, find the intercept, and see if that's moved over that much.
I just graphed it.
Did you just graph it?
Yeah.
And it's minus 2/5 like to the left?
Yeah, the
Okay.
limit is -2.
So our asymptote here is currently at 0 still after this compression. But this, if you write it in this form, this would be a movement to the left of 2/5. So that asymptote should be here at negative 2/5. And if you've graphed that, you've confirmed that? That looks good. Okay. So the graph should look something like this. You don't have to draw that. But the domain would be x is greater than, not equal to, but greater than negative 2/5. And that's all you need to put. X comma, XER, or whatever, I don't care, comma XER. Okay, so that's confirmed that that's what that is for A?
Yep.
All right. So I guess the big thing is the transformations, and I would suggest that, let's just adjust this, that this has to be like this. Okay, so that b has to be factored out of that x. And then you've got your true c, which is the translation left-right. Sorry, I kind of forgot about you.
Based on the math, right? For this.
So number 5 on the same section, which is this is 8.3. Okay, so we're solving for x. Okay, now if you took the ln of both sides, the natural logarithm of both sides, then ln of e to the power of, that would cancel out, right? If you remember, ln of, where is it? My computer's lagging. It's lagging big time. Right here. Ln of e to the x, power of x, is x. So we're going to use that truth right here in answering this. So then that means that 5x plus 3 equals ln of 10. And remember, that's just a number. So let's isolate for x. So 5x equals ln of 10 minus 3. And then x equals ln 10 minus 3 over 5. And I'm okay if you just leave it like that. Yeah. No, sorry. The question asks for decimal places. Yep. So we'll have to plug that into our calculator. No problem. We can do that. It's okay. The calculator doesn't mind doing the heavy lifting here. All right. So, yes, ln of 10 minus 3. We'll make sure we pay attention to our brackets closely there. Divided by 5. Does that look like the answer you're expecting?
Yes.
Negative 0.13948? Okay, excellent.
If we're on 8.3, could we do 3F?
We probably could do 3F there, yeah. Are we satisfied with this number 5 there yet? Do you want me to do the D as well? So the D, you'd have to take the well, let me see. What would you do there? You could take the natural logarithm of both sides as well. Yep.
You could also like do log base 2.
Well, yeah, you could do log base 2 to both sides. Yeah, but natural logarithm is going to be the default one. But you could do log base 2, yeah. I don't know which one would be easier. If you were probably not a good idea to have a base other than 10 or e, maybe for logs, just for your calculating purposes. I don't know, it might be a little extra work, but yeah, you could. Did you do that one that way? Did you log base 2? Yeah, I think that would be fine. I would suggest that ln is just as good. So we have x minus 5 as now a coefficient times ln of 2 equals ln of 3. X minus 5 equals ln of 3 over ln of 2. And ln of 3 over ln. Are there any rules for this? Natural logarithms being divided like that? Sorry, plus 5. So change the base formula. We could go change the base formula in reverse, I guess. So suppose what would that look like? You could go ln of 3, or see, you have to now change it to logarithm of 3 base 2. So I don't know if that's logarithm of 3 base 2 plus 5. That we're doing decimals, so it doesn't really matter, I think, which one you evaluate. But yeah, that change of base formula could look like that too. Yeah.
So then you have 1 plus.
But could you also just put in ln of 3 over ln of 2?
Yes. Yeah. We're just doing calculator work here, so you're right. It doesn't. Let's just double check. We'll double check to make sure these are the same. But I think this Like either one of these would be fine right here. This one or this one should be the same value. So let's just check that. Ln of 3 divided by ln of 2 is plus 5.
What is that?
And now I think it has to be this. I don't have this function on my calculator to put in different bases, so that's the way I would do it anyways. So it should be 6.58496 3 1 2 3 4 5 6 6 decimal places, so 6.584963. Okay, there it is. Yeah, you're welcome. You're welcome. Sorry, did you have another question about 8.3? 3F 8.3. There's here, this one, ln 2, 2 ln 3 minus ln 18, that one?
Yeah.
Did we do that one? Did we do that one yesterday?
You did it with us.
Yeah, I was there for it. Wait, no, that's it.
Is that the one you're looking for?
Yeah, that's it.
Okay, let me just make some space.
I genuinely don't understand 7C.
Come on now, make some space here. Okay, so we can use our logarithm rules as if my computer would actually throw me a bone here.
Is there a list of ln?
Yeah, it should be a list of logarithm rules in possibly chapter 6 there. I can help you find some in a second. Okay, so first thing is first, what you could do is put this 2 up as an exponent, so you have ln of 2 plus ln of 3 squared minus ln of 18. So that would be first things first, so that's actually 9, right? Now with logarithms, when you add logarithms like this, that's the same as writing the product of these two in one single logarithm. So that's 2 times 9. And so that's actually ln of 18 minus ln of 18. Another logarithm rule is when you subtract, similar to adding, instead of multiplying, you divide. So you could write this as a single logarithm with 18 divided by 18. So,
You did the same base stuff?
well, these all do have the same base. Yes, they have to have the same base in order for that to happen. That's correct.
Wait.
So this is ln of 1, which is 0. So the answer, I think, should be 0 there. Yeah? Okay. 3F, does that help? Makes sense. Of course. Yeah, you would notice here that right at this stage that would be 0. Yeah, for sure. By taking it further, I'm just want to go over the ln rules with you because somebody just asked about the logarithm rules. Did you find the logarithm rules in your text there, or do we have to look those up?
Is there like one place where they are?
So these are the important ln rules. They are on page 373 in your Red Stewart Calculus text, Calculus first course we're using.
Power. That power should be
Okay. Okay, good. And sorry, what was that other question? Okay, 8.44C. Differentiate. Okay.
I like that.
Okay, so this is from 8.4, differentiating exponential stuff, I guess. So C, specifically you wanted? So 5 to the power of root x. Okay, so let's just focus on 5 to the power of root x. So that's in the, I guess that's in the sort of realm of b to the x. Actually, that's b to the u, since that's not just an x. So do you remember doing the derivative of b to the u, or b to the x even? What is that? It's b to the u ln b, right? And then if it's a u, so you multiply by u prime at the end. Or I should keep my notation. So du dx multiplied by du dx. So that's the chain rule of this derivative rule, okay? So we're gonna have to keep that in mind when we get there, but this is a product rule situation because we clearly have two functions, x, and then we have multiplied by 5 root x. So those are two functions multiplied together, so we're gonna do product rule. Does that make sense? Did you see that? Okay. So y prime is gonna be the derivative of the first times the second. So derivative of the first, again, we're differentiating, and it's with respect to x if it's not indicated. So that's going to be 1 times 5 root x plus the first, now times the derivative of the second. So this is where it gets maybe a bit messy, but it's going to be the derivative of an exponential function is just itself. It's always just itself. Then you're going to have to multiply by the natural logarithm of the base. That's 5. And then chain rule says I need to multiply by the derivative of this because I haven't touched root x yet. I haven't taken the derivative of root x yet. So that's going to be times 1/2 x to the negative 1/2. Is that right? Yeah, okay, so that gets a bit messy there, but that's the derivative of 5 to the power of root x. Everybody okay with that? All right. Okay, so we should simplify. If the question on the test said differentiate, do not simplify, you could stop right away, right there, and you could stop right there, and that's all you have to do. Normally, we would have to. Normally, we should simplify. So what I see here is we do have 5 to the root x as a factor in both terms. This is one big term here. We got a plus sign, and then another big term over here, right? So we have also. This can be moved down to the denominator, x to the negative 1/2. So we could write that sort of in the denominator too. So let's just start to chip away at the simplification here. If we take out the 5 root x first, which you could, then you're going to have 1 plus. Now we're going to have x times 5 root x times ln 5. Sorry, the ln 5's gone. Thank you. Over 2.
No, the 5 root x is gone.
Yeah. Well, why don't we keep the ln 5? Yeah, I like that ln 5. So these are gone. I should have used a different pen for that. Good, thank you. Okay, all good? Ln 5. So the 2's on the bottom, and this root x is on the bottom. Okay.
Where did we get the 2, sorry?
The 2, this one? From the chain rule here, derivative of that one. Okay, now again, how far do you go? Is this cool? Yeah, this is fine. I think that's fine. X ln 5 over 2 root x. Could you simplify these x's? I think technically, but what do you end up with? That's a 1, and that's a 1/2. So what's 1 minus 1/2 is just 1/2. So you have a root x on top instead of on the bottom. So that might be the one thing you might want to do.
That's what they did.
Did they just leave it here?
No,
They did one more step, yeah. So if you have a common variable term on top and the bottom of the same ratio, you should simplify that, I guess. So that would be the one final thing that I would suggest doing. But again, this is tough to know when to stop. But this is like ln 5 root x or root x ln 5, doesn't matter, just over 2 then. Is that correct? It's because we got 1/2 up here. So 1, x to the 1 and x to the 1/2. That's x to the power of 1 minus 1/2, which is just x to the 1/2. It's positive, so it's on top. And whether they put the root x in front of ln 5 or behind, I don't really know.
They took a 1/2 out of the factor of that.
They factored the 1/2 out of what? Out of this? Like took the 1/2 out of here? They don't like
They
the.
just have a 1/2 outside with the 5.
Oh, they have this over 2, and then this would be over 2. I don't know.
Yeah.
1 divided by half. This should be 2 then. I don't know. This is fine.
While we're here, can we do A quickly?
So not that it's necessary, but they do divide a 1/2 out of this, and then this is a 2 then, and this is a ln 5 times root x. So I don't know. The book maybe likes that better. I don't really care. Both these are fine. Okay, you've attempted a good factoring there, so that's good. You got the x's so simplified. Okay, so there was another couple questions
I was
about.
just asking if we could do A while we're.
Do A while we're at it there, eh?
Yeah, let's do it. Let's go.
Okay. You guys love this. I'm just doing all your homework for you, huh?
Yeah.
Yeah. You're not even being, yeah, you're getting the, from your classmates over there.
Huh?
Huh? All right. Okay. Okay, so what would you do first, Thomas?
You take the derivative.
You take the derivative.
Wow.
Wow. That is profound.
I've attended this class.
Okay. What's the derivative of this first one? This is the toughest part of the
3x
one.
squared. Oh. Oh, oh,
It's not the toughest part, but yeah, good job. Just
I
kidding.
know, I just didn't want to have to do this stuff.
You didn't want to have to do the second one. Okay.
Just kidding.
This is in the form of b to the x, guys, right? So the derivative, that form is b to the x ln
3x on
b. That's that.
genius.
That's that. So it's 3 to the x ln 3.
So,
This is just x, so chain rule is like times 1.
yeah.
So no chain rule? Yep.
Per se, the question was squared x. No, e to the x.
Good. This way. Are we done here first?
Yes.
Before I move on to finish all of your homework for you?
Can't you take out a 3x?
This is actually
Well, that's a good question. I was wondering if someone was going to say that. This is a 3 times x times x. This is a 3 to the power of x. So these are not the same. You can't really factor anything out there because one is an exponent.
Oh, I see.
Yes.
X to
I know, my
the
poor handwriting is,
You had X to the
although you should be able to understand poor handwriting.
Me or him?
Oh.
Both of you. It
My
applies.
handwriting is legible, it's just in weird places. His is just chicken.
Mine is legible.
It is not legible.
There's nothing wrong with
All right. Don't hurt each other.
It looks like you know those like horror movies where like they find like a notebook and it's like those
Yeah.
like scrolls,
Like,
you know?
it's like a notebook from a horror movie.
That's what his math looks like. He
Okay.
looks like he's in a dark forest and he's about to get hunted and he has to finish these math equations or else he'll get killed. But he's writing them as frantically as possible.
Yeah, there's like a goblin that's like, if you don't finish this
Little things.
All right. You guys are entertaining. That's for sure. Does anyone have another question for me? Because I know you want me to do your homework for you.
Wait, is that it? Per se.
I don't know. Is that it? Are we done?
Can't
That's it.
simplify it.
It is
I think the one recommendation I struck down. So I don't know. Is there another recommendation?
Yeah, I was about to say that. Why don't we
Number 7.
That's good. That's done. Sorry, what?
8.7, number
Just
7.
take the second derivative.
Okay, 8.7, number 7c.
I figured it out. It's really nasty.
The
8.7, 7c.
Yeah, I figured it out.
Oh, do we want to do a real nasty one? Oh, this one? That looks so harmless.
I
Oh, wait,
know,
that one?
but then
Oh,
I
never mind.
looked
7C?
at it, and then
Isn't
I
that
looked
it?
at the- yeah, and then
Never
I looked
mind.
at the back
I
and I
didn't
got
do
a
that.
very wrong answer. And so
Really?
I think I simplified it wrong.
That looks very harmless.
I know, that's what I thought.
Okay, from the review, this is 8.7.
Well, e to the
7C.
x is basically-
Yeah, the derivative of e to the x is tough. That one's tough.
Basically, very tough.
All right, the derivative of this product rule. Did you notice that's product rule? All right, awesome. So what's the derivative of the first? Because product rule is like this, right?
A half x to the negative half.
1/2 x to the power of negative 1/2. I like it.
Yeah.
Derivative of the first times the second. Plus the first.
Straight up.
Do you want to do root x or x to the half? What do you think? Root x, sure. The first times the derivative of the second, e to the x.
Yeah.
All right. So that's the first step. That's differentiation. That's using the power rule and all your rules. Okay, so now simplifying. This would look, this 2 is on the bottom. This is a 1/2 root x, and then times e to the x. So this would simplify to something that looks a little more like this, I would say. And then root x e to the x. So what they might want you to do is to combine that into one term, perhaps. That would probably be what they would want you to do to simplify. So if you went 2 root x and 2 root x top and bottom, then you would get something like this. You get e to the power of x over 2 root x. Plus, you'd get 2 times e to the x times x. Root x times root x. That's root x squared, which is just x, over 2 root x. And now we have a common denominator of 2 root x. And I have e to the x in both terms, so you can factor an e to the x out. And I go 1 plus 2x maybe.
Oh yeah,
That's what I'd like to do.
Yep. Friend, I was just lazy. I wasn't, I just actually did not realize.
Okay.
At least she's honest.
Yeah, at least she's honest. Yeah. That's
And
good.
then I took him back because I was joking.
Math, honesty is very important.
That's what.
All right, I'm doing more of your homework for you if anyone's interested.
Yep. Which one? Oh,
Which one?
we just did that.
8.4, 5a.
What?
The equation of the tangent line.
Can you do B? We just did this one.
Okay.
Oh, yeah, nice.
Do C, do C, do C, do C.
Do A.
Is C part of the assignment as well?
Yes.
All right, fine.
No, it's not.
What?
Yes, it is.
5C? It is or it's not?
Yes. 5AC.
I don't remember it.
Okay.
No, I just
Okay,
finished it.
here is 5C, since some of you have already done A.
Wow.
Okay, 8.4, 5A. All right, 5C. Okay, guys, here's 5C. Now, remember this. Equation of the tangent line means that we need to find the derivative of the function, which is the expression for the slope of the tangent line. You need to plug the point in, like the x value at least of the point, to find the actual slope of the tangent line at the point of tangency. Then once you have the slope, you use that point of tangency to determine the equation of the line. So we did this chapters ago. Now we're just finding derivatives of functions that you just learned how to find the derivative for. So this is a b to the power of x one, right? So the derivative of b to the x is b to the x ln b. So y prime is 10 to the x ln of 10. We okay with that? Okay. So that's the expression for the derivative, which means that I can plug any old x value in I want into here, and it will give me the unique slope of the tangent line at that x value point. So if I want to find out what is the slope at 1, I go 10 to the 1 times ln 10, which is just 10 ln 10. And you're going to use that right there as your slope value. Okay, don't do a decimal, just leave it like that. So 10 ln 10 is going to be the exact slope of the line there. So that's the slope, right, at the point 1 comma 10. And you can use notation like this if you want, but that's the slope at slope of the tangent there. Okay, and the next part is y minus y1 equals m times x minus x1. And so you want to try and find a point that you know is on this graph, which, boom, this one's given to you, the tangent. Actually, you have to use the point of tangency, because that's the point that goes with the tangent line that we found the slope of. So it's y minus 10 equals m, that's 10 ln 10, x minus 1. And that would be fine for an equation of a line in the point slope form. They may ask you for a different version, which y equals mx plus b is usually pretty good. So y equals 10 ln 10x minus 10 ln 10 plus 10, because you bring this over, right?
So what question is this?
Isn't that 5? This is 5c, 8.4.
Yeah.
Okay, so let me just see if I see. So, yeah. I think they give this one in the answer key. Or, oh, yeah. They don't give the y equals mx plus b form, but this would be it. Okay, that's C. Now A, I can do A for you as well. I can do A for you as well. That's not a big deal. Everybody good with C here, though? You were yawning and talking. I noticed that. Okay. Yeah, you're multi-talented. All right, so easy peasy here. What's the derivative of ln? Who remembers what the derivative of ln is?
1 over x.
1 over x. So if it's not just x, it's 1 over whatever's in there.
Yeah.
And then we multiply by the derivative of the inside function, which happens just to be 1. So it's just 1 over x minus 1. Everyone cool with that?
Yes.
So the slope, that is the evaluation of the derivative
Tell myself
at x equals 2, because that's the point in question, is 1 over 2 minus 1, or 1.
1.
So the slope is 1 here. Y minus 0 equals 1 times x minus 2. Boom.
Simple slope.
X minus 2.
That's beautiful.
There we go, right? X minus 2. Yep. Boom, done. 5a. Y equals x. Y equals x.
Ln of sine of x.